it's not quite as simple as it seems when you're talking about aircraft, is it?
No, not at all. It might seem basic, but it's the foundation
Yeah.
upon which everything else is built.
Okay.
Think about, for example, calculating the weight and balance of an aircraft.
Okay.
You're adding the weight of the passengers, the cargo, the fuel, every single component.
Yeah.
And being off by even a small amount could shift the center of gravity and impact the aircraft's stability in flight.
Yikes. Oh, so addition is super important.
Definitely.
That's subtraction.
Subtraction. Oh, that comes up all the time.
Yeah.
Like the handbook uses the example of figuring out how much materials is left after a repair, right?
Oh, right. Yeah.
It's not as simple as just eyeballing it.
No, I guess not.
Let's say you're patching a hole in the fuselage, okay?
Okay.
You need to subtract the area of the patch from the sheet metal you have on hand.
Right.
And you have to be precise to make sure you have enough material to complete the repair and maintain the structural integrity of the aircraft.
Oh, wow. Yeah, that makes sense.
It's all connected.
Okay, so what about multiplication? That's got to come up, right?
Multiplication. Oh, absolutely.
Yeah.
The example from the handbook about hydraulic filters, that was a good one.
Yeah, it caught my eye.
Imagine you're preparing for a major maintenance check, right?
Okay.
And you need to replace all the hydraulic filters on a whole fleet of aircraft.
Oh, wow.
So you're multiplying the number of filters per aircraft by the number of aircraft, and that gives you the total number of filters you'll need to order.
That makes sense.
It's all about efficiency and making sure you have the right parts on hand.
Right, right.
You don't want to be in the middle of a job and realize you're missing something,
No, definitely not.
especially when it comes to aircraft maintenance.
Yeah, no room for error there.
Not at all.
So we've covered addition, subtraction, multiplication.
Right.
What about division? How does that factor in?
Division. Okay, well, let's say you're tasked with evenly distributing a set of specialized bolts
Okay.
among several aircraft undergoing maintenance.
Right.
You'd use division to make sure each aircraft receives the correct number of bolts.
Oh, that makes sense.
It seems simple, but it's about accuracy and resource allocation.
Right, and making sure that everything is done,
Exactly.
correctly.
Yep.
Okay, so we've talked about those 4 basic operations.
The foundation.
But what about fractions? The handbook really stresses how important those are.
Fractions are essential because they represent those real-world measurements that don't always fall neatly into whole numbers.
Yeah.
Think about the thickness of an aircraft skin, the diameter of a rivet, the spacing between components. These measurements are often expressed in fractions of an inch.
Right, and it's not like you can just round up or down, can you?
Not usually, no.
So what's a real-world example where fractions are absolutely crucial?
Okay, let's say you need to determine the total thickness of a section of the wing.
Hmm.
And this involves layers of skin, sealant, and paint, right?
Yeah.
Each layer might have a thickness measured in a fraction of an inch.
Yeah.
To get the total thickness, you got to add those fractions together.
Right.
And sometimes, they have different denominators,
Oh, yeah.
which adds another layer of complexity.
Right, so it's not just about knowing what a fraction is.
Yeah.
It's about applying that knowledge to real measurements.
Exactly. Another good example is calculating the travel distance of a jack screw, from a neutral position.
Okay.
If the jack screw moves in opposite directions, you need to understand how to subtract fractions with different denominators to accurately determine the total travel distance.
Okay, so that's fractions.
Yep.
What about mixed numbers? How do those come into play?
Mixed numbers are everywhere in aviation.
Are they?
Oh yeah, think about calculating the available cargo space after removing rows of seats.
Okay.
You'll likely end up with a mixed number, like 12.5 feet or something.
I can see that, yeah.
You've got the original length of the cargo space,
Right.
and you subtract the space occupied by the removed seats.
Right.
Boom. You've got yourself a mixed number,
Yeah.
and sometimes you might even need to borrow from the whole number when subtracting, just like you would with regular subtraction.
Okay, got
It
it.
can get a little tricky.
Yeah, so we've got fractions, mixed numbers. What about decimals? Those always seem a bit more technical.
Well, decimals are just another way to represent parts of a whole.
Okay.
And they're incredibly important in aviation because they allow for those precise measurements and calculations.
So decimals are all about precision.
Precisely. For example, think about fuel calculations.
Oh, okay.
Aviation fuel is measured in pounds, and the weight of fuel can vary slightly depending on the temperature.
Right.
So you might need to use decimals to calculate the precise weight of fuel needed for a specific flight.
To make sure that you're not overloading the aircraft or anything like that.
Exactly. You don't want to be too heavy or too light.
Right, and decimals help with that.
Exactly.
They make sure that everything's balanced.
Precisely.
Okay, what about those really long decimals? Sometimes those can be a bit intimidating.
Oh, absolutely, which is where rounding comes in.
Oh, okay.
It's about simplifying those long decimals to a level of precision that's appropriate for the task at hand. For instance, when you measure the diameter of a bolt, you might round to the nearest thousandth of an inch. But when you're calculating fuel weight, you might round to the nearest tenth of a pound.
Got it.
It's all about context.
So choosing the appropriate level of precision.
Exactly.
Okay, so we've talked about fractions and decimals separately,
Mm-hmm.
but mechanics often need to switch between the two, right?
Oh, yeah. All the time?
That's got to be tricky.
It does take some practice.
Yeah.
Let's say you're working with a blueprint that specifies a measurement in decimal inches,
Okay.
but your socket set is labeled in fractions.
Oh, right.
You need to be able to convert that decimal to a fraction to select the correct tool.
And the handbook has a whole section on that, right?
Yes, it uses that socket size example,
Okay.
and it walks through how to convert a decimal like 0.625 inches to its equivalent fraction,
Right.
which is 58 of an inch.
Right. So being able to switch back and forth between fractions and decimals is really important.
It's essential.
What about going the other way around?
Going from a fraction to a decimal.
Yeah.
Oh, that's important too.
Yeah.
Like imagine you're drilling a hole that needs to be slightly undersized.
Hmm.
The blueprint might specify the hole size as a fraction,
Okay.
but your drill bit set might be labeled in decimals.
Gotcha.
So you need to convert that fraction to a decimal to select the correct drill bit.
So it's basically like learning a whole new language.
Kinda, yeah. It's like being bilingual in fractions and decimals.
Right. I like that analogy.
And the handbook, it even provides a handy chart for converting between fractions and decimals.
Well, perfect. So you
Yeah.
don't have to memorize everything.
That's right. Although understanding the process is still important.
Yeah, of course.
Sometimes when you convert a fraction to a decimal, you end up with a repeating decimal, like 0.333333.
Right. Those are fun.
The handbook explains how to round those repeating decimals to the appropriate level of precision.
Okay. That's good to know.
It's all about making those numbers work for you.
So we've covered a lot in this first part of our deep dive, from whole numbers to fractions, decimals, and converting between them.
It's a good foundation.
And I know there's a lot more to come.
Oh yeah, we're just getting started.
So buckle up, everyone, because we're about to dive even deeper into the world of aviation mechanic math in part 2.
It's going to be a wild ride. All right, so we just finished talking about whole numbers, fractions, and decimals,
Right, the basics.
and how important they are in aviation maintenance.
Yeah, it's amazing how much those fundamental concepts come up.
Oh, absolutely.
But I know there's a lot more to cover.
There is. Now let's shift gears a bit and talk about ratios and proportions.
Okay, ratios.
These concepts are essential for understanding how different components in an aircraft work together,
Okay.
how systems perform, and even how aircraft are designed.
I remember ratios from, way back in school,
Uh-huh. Yeah, we all do.
but I'm not sure I ever fully grasped how they're used in the real world.
Right.
Especially in aviation.
Okay, well, think of a propeller, for example.
A propeller. Okay.
The ratio between the propeller's diameter and its pitch,
Yeah.
that determines how efficient the propeller is and how much thrust it generates.
Wow. I never thought of it that way.
Yeah, different ratios are good for different things.
Okay.
A higher pitch ratio might be better for high-speed flight, while a lower pitch ratio could be more efficient for takeoff and climb.
So the ratio really affects how the aircraft performs.
Absolutely. And then there are gear ratios, which are crucial for understanding how power is transmitted within an aircraft.
Gear ratios.
The handbook uses a really good visual for this one.
Oh, yeah.
An image of a pinion gear and a spur gear
I see it.
to illustrate this concept.
Yeah.
You're basically comparing the number of teeth on each gear
Right.
to determine the speed and torque relationship between them.
So a gear with more teeth rotates slower but with greater torque.
Exactly.
And a gear with fewer teeth rotates faster but with less torque.
You got it. And understanding these relationships is essential for diagnosing problems with transmissions, hydraulic systems, and other mechanical systems.
Oh, wow. So gear ratios are really important for troubleshooting.
They can tell you a lot about how a system is functioning.
That's really cool.
And then there's the concept of speed ratios, which are basically the inverse of gear ratio.
Okay, CP base.
As the number of teeth on a gear decreases, its rotational speed increases.
So it's a trade-off between speed and torque.
Exactly. It's all about finding the right balance for the specific application.
And you can calculate all of this using ratios.
Precisely. The handbook provides some examples of calculating gear speeds, which would definitely come in handy for a mechanic working on these systems.
That's great. So we've talked about ratios.
Mm-hmm.
What about proportions? How are they different and how are they used in aviation maintenance?
A proportion is simply an equation that states that two ratios are equal.
Okay, so it's like saying this ratio is equivalent to that ratio.
Exactly. Let's say you're trying to calculate the amount of de-icing fluid you need to mix for a specific allocation.
Okay, de-ice and fluid. Got it.
The mixing ratio might be specified as a proportion, like 1 part de-icing concentrate to 4 parts water.
So you're using the proportion to figure out how much concentrate and how much water you need to mix together?
Precisely. Proportions are also used in fuel calculations.
Fuel calculations, okay?
If you know the fuel consumption rate of an aircraft and the distance you need to fly, you can set up a proportion to calculate the amount of fuel required for the trip.
That makes sense. So proportions are really about comparing and equating different
You
quantities.
got it. It's a powerful tool for making sure things are balanced and that systems are operating as they should.
This is all making a lot more sense now.
Good. I'm glad to hear that.
All right, let's move on to percentages.
Percentages.
Yeah, those are everywhere, but I'm curious to hear how they're used specifically in aviation maintenance.
Percentages are special types of ratios that represent parts out of 100.
Right, out of 100.
You'll see them in technical data, performance calculations, even when analyzing the results of inspections.
So how are they used in a practical sense?
Okay, let's say you're inspecting a batch of wingtip lights,
Okay, wingtip lights.
and you find that 5 out of 100 are defective.
Okay,
You can express this as a percentage, 5%.
right. That's
And
okay.
this percentage gives you a clear indication of the defect rate, which is useful for tracking quality control and making decisions about replacement parts.
So you're using the percentage to quantify the defect rate.
Exactly. Percentages are also used to calculate the efficiency of components, like motors and generators.
Okay, efficiency, got it.
For example, if a motor is 85% efficient,
Mm-hmm.
it means that 85% of the electrical energy it consumes is converted into mechanical power,
Okay.
while the remaining 15% is lost as heat.
So percentages help you understand how well a component is performing.
Exactly. They give you a way to measure and compare performance.
That's really useful.
And sometimes, you need to work backward from a percentage to find an unknown value.
Okay, working backward.
The handbook is a good example with a microphone resistance value.
All right, microphone resistance.
If you know that the resistance has decreased by 10%
Okay.
and the current resistance is a certain value,
Mm-hmm.
you can use algebra to find the original resistance.
So percentages can be used in all sorts of calculations.
They're a versatile tool.
Okay, so we've got ratios, proportions, and percentages.
We're making progress.
What's next?
Okay, so we've talked about a lot of different mathematical concepts so far.
We have from basic arithmetic to algebra, percentages, ratios,
Powers and roots.
scientific notation. It's a lot.
It is. But these are all really important tools for any aviation mechanic.
And I know there's even more to cover.
There is. Now we're going to talk about area, volume, surface area,
Yeah.
and even a little bit of trigonometry.
Trigonometry, really?
Yep, it might sound a little intimidating,
A little bit.
but trust me, it's all relevant to aviation maintenance.
Okay, I'm trusting you.
Good.
Okay.
So let's start with area.
Area.
That's the measure of a two-dimensional surface, and it's expressed in square units, like square inches or square feet.
Okay, so like if you're painting a wall, you need to know the area to figure out how much paint to buy.
Exactly. And in aviation, imagine you're patching a hole in the fuselage skin.
Okay.
You need to calculate the area of the patch to determine how much material you'll need.
Makes sense.
But aircraft have all sorts of complex shapes, right?
Yeah, wings, fuselages, tail sections.
Exactly. So how do you calculate the area of those?
That's a good question.
Well, the handbook provides a table with formulas for calculating the area of various shapes.
Okay, so there are formulas for everything.
Pretty much. You've got rectangles, squares, triangles, trapezoids, circles, ellipses, even wings.
There's a formula for calculating the area of a wing.
There is. It involves the wings, span, chord length, and taper ratio.
Wow, that's pretty complicated.
It is, but it's important for understanding how the wing generates lift and how much drag it creates.
I see. So area calculations are really important for understanding how an aircraft performs.
Absolutely. And of course, understanding area is crucial when working with sheet metal.
Right, because you need to know how much material you need for repairs or modifications.
Exactly. And you need to be comfortable converting between different units of area, like square feet and square inches.
Because sometimes the blueprints will use one unit and your tools or materials might use another.
Exactly. It's all about being able to translate between different systems of measurement.
Okay, so we've talked about area.
Mhm.
What about volume?
Volume is the amount of space inside a three-dimensional object.
Right, so like a box or a cylinder.
Exactly. And in aviation, think about fuel tanks, cargo compartments, even the cylinders in an engine.
Okay, so volume is important for figuring out how much something can hold.
Precisely. You need to understand volume to determine their capacity and ensure they're filled correctly.
And this is where we start talking about cubic units, right?
Yep, cubic feet, cubic inches, that sort of thing.
And there are formulas for calculating volume too, I assume.
Of course. The handbook has formulas for rectangular solids, cubes, cylinders, spheres, cones, you name it.
I'm starting to see a pattern here.
Haha, there's a formula for just about everything.
Okay, so we've got area and volume.
We're on a roll.
What about surface area?
Surface area is a little bit different.
How so?
It's the total area of all the surfaces of a three-dimensional object.
So, like, if you were wrapping a present, you need to know the surface area to figure out how much wrapping paper you need.
Exactly. In aviation, think about painting an aircraft.
Oh, okay.
You need to know the total surface area to calculate how much paint you'll need.
That makes sense.
Or imagine you're designing a heat sink for an electronic component.
A heat sink.
Okay, the surface area of the heat sink determines how effectively it can dissipate heat.
So surface area is important for both aesthetic and functional reasons.
Exactly. It's
Yep.
all about understanding the exterior of an object.
Whereas volume is about the interior.
Precisely.
Mm-hmm.
And just like with area and volume, the handbook provides examples of calculating surface area for different shapes.
Okay, so we've covered area, volume, and surface area.
Just one more to go.
All right, bring on the trigonometry.
All right, trigonometry, it's the study of triangles.
Triangles, okay.
And you might not think it's that relevant to aviation maintenance.
Yes, I was kind of wondering about that.
But it's actually more important than you might think.
Really? How so?
Well, it's all about the relationships between the sides and angles of triangles.
Okay.
And those relationships come into play in areas like navigation,
Navigation, okay.
determining the forces acting on aircraft structures, even calculating weight and balance.
So give me a concrete example of how trigonometry is actually used in aircraft maintenance.
Okay, imagine you need to determine the length of a cable needed to support a section of the wing.
All right, wing cable, got it.
You know, the angle at which the cable is attached.
Okay.
And the distance from the attachment point to the wing strut.
Hmm.
Using trigonometry, you can calculate the length of the cable.
So you're using angles and known distances to solve for an unknown length.
Exactly. Trigonometry can help you figure out all sorts of measurements.
That's pretty cool.
And the handbook even highlights the Pythagorean theorem.
Oh yeah, a squared plus b squared equals c squared?
That's the one. It relates the lengths of the sides of a right triangle.
Right.
And it can be used to solve for unknown distances or to check the accuracy of measurements.
I remember learning that in school, but I never thought I'd actually use it in the real world.
Well, in aviation maintenance, you never know when you might need it.
That's true.
The handbook gives the example of fitting a large steel plate through a cargo door.
Oh yeah, I remember that one.
You can't fit it straight through,
Nope.
but you might be able to fit it diagonally.
Right.
And the Pythagorean theorem can help you figure out if that'll work.
So it's a real-world application of a mathematical concept.
Exactly. It's not just about abstract numbers.
It's about solving problems and getting the job done.
Precisely.
Well, we've covered a lot of ground in this deep dive.
We have, from the basics all the way to trigonometry.
And it's clear that math is an essential skill for any aviation mechanic.
It's not just about turning wrenches.
It's about understanding how those wrenches work, how the systems they're working on function.
And how to keep those planes flying safely.
Math is a crucial part of all of that.
Absolutely. It's about precision, accuracy, and safety.
And I think we've demonstrated that pretty well today.
I hope so.
So, to all of you out there who are thinking about a career in aviation maintenance,
Or who are already in the field.
don't be intimidated by the math.
Embrace it.
It's a challenge, but it's a rewarding one.
It'll make you a better mechanic.
And it'll help you keep those planes in the air.
Safe and sound.
That's all for this deep dive, everyone.
Thanks for joining us.
We'll see you next time.